Today's problem is rotated array. This is on interview bit. And at this point, go ahead and pause the video, go over to interview bit, try the rotated array problem, and then come back. We'll walk through the solution. All right. Difficulty easy. Asked at Facebook, or Meta, I guess I should say. Problem description. Suppose a sorted array, A, is rotated at some pivot unknown to you beforehand. For example, 1, 2, 4, 5, 6, 7. That is a sorted array. Now, we could rotate it, moving, depending on how you want to think of it, moving some of the elements from the end to the beginning, or some of the elements from the beginning to the end. But in any case, it's been pivoted here to be 4, 5, 6, 7, 1, 2. Find the minimum element. The array will not contain duplicates. Note, use the circular rotated property of the array to solve the problem. That seems to be pointing us in the wrong direction, the way I read it, but I don't know. We'll come back to that. Problem constraints. Length of A is between 1 and 10 to the 5th, 100,000. Elements in the, I keep saying array. I mean, actually, we're getting a list in here in the Java template. The numbers will be between 1 and 1 billion. Input argument is an integer array or list. Output format is the minimum element of the array or list. Now, these examples are not that useful because you can just look at them and see what the minimum element is, but it doesn't really illuminate how you might want to go about finding the minimum element. The note they give us is use the circular rotated property to solve the problem. It seems like what that is pointing us at is take a linear pass through the array. It's circular, it's rotated, so when you find a number, like in this case, let's say the number 1, when you find a number that's less than the previous number, that's the minimum number. That's not the best way to do this. That's an O of n algorithm, and n, well, the length can go up to 100,000. So we're looking at on the order of possibly 100,000 comparisons. I would say use the sorted property of the array to solve the problem, and the fact that you can do a binary search on a sorted array or list, even if it's rotated. So now you've got an O log n solution. And for 100,000, how many comparisons, worst case, to binary search 100,000 elements? It's definitely less than 20. Not sure what it is exactly. 2 to the 20th is around 1 million. So yeah, so I mean 20 is a lot less than 100,000. So the way we want to do it is with a binary search. So let's take a look at this. Find min. This is the method template that we're given. A list comes in. We'll get the size of the list, and then we'll do a comparison between the first element of the list and the last element of the list. And if the first element of the list is greater than or equal to the last element of the list, that means that the whole list is sorted. Now, there's nothing in here that says that, well, it's pivoted in some way that you don't know. Maybe it's not pivoted at all. It doesn't say. Or maybe it's pivoted in a way that it just returns to its original shape. So, we need to check that. It's an edge case. Do we need to say less than or equal to, given that there will be no duplicates? And I would say yes, because it's also given that there could be only one element. So if there's only one element, then yes, the first element would be equal to the last element. All right, assuming that this edge case doesn't hold, we're going to go to binary search. So can I get a little bit more space here? Do I have enough space to do this? Yes, I think so. We're going to use this array here as an example. And for the binary search, there's three variables that we need to keep track of: low, high, and mid. So let's get that, and let's say we have low, we have high, and we have, I'll just say M for mid. All right, the first time we come into the binary search, low is 0. High is size minus 1. Now the size here is 6, so minus 1. High is 5. Mid has not been computed yet. So let's go in here. If low is greater than or equal to high, that means we have run out of space. The low and high indices have converged, and so we return the number that we have left. That's not the case. Mid is low plus high divided by 2, 5 plus 0 divided by 2. 5 divided by 2, integer division would be 2. All right, nums at 0. Is that less than or equal to nums at mid, which is 2? So what we're looking at is this, 4 and 6. And nums at 0 is less than nums at mid, which means that the minimum cannot be in that sequence, because what we have there is a sorted sequence. The only way that mid could be there is if the entire array were sorted, and then 4 would be the minimum element. Assuming that we have rotated some of the items at the beginning of the original list to the end, that sequence cannot contain the minimum element. So this, okay, what is it, less than or equal to nums? Okay, so that is true. Okay, so now we do another binary search. Low becomes mid plus 1. Okay, low becomes 3. So we've essentially eliminated these from consideration. High stays where it is, and we'll go through again. Is low, and let me erase these, those are just a distraction at this point. Is low greater than or equal to high? No. Mid is low plus high. 5 plus 3 is 8 divided by 2, so mid is 4. All right. Is nums at 0 less than or equal to nums at 4? Nums at 4 is 1. So is 4 less than or equal to 1? No, it's not. So wait, where is mid? Okay, yeah, that's fine. So we are going to drop into the second option, which is nums low. Low stays where it is, but high becomes mid. So high is now 4. Okay, let's go around again. Is low greater than or equal to high? No. Mid is low plus high divided by 2, which is 4 plus 3, 7, divided by 2, integer division, is 3. All right. Nums at 0, is it less than or equal to nums at 4? Wait. No, mid. I'm sorry. Mid is 3. Is it less than or equal to nums at 3? And the answer is yes. So again, that's just a sorted sequence, and it means that the min cannot be in there. So we can actually eliminate that. So we'll do the a binary search again. First option, nums low becomes mid plus 1, which is 4. High stays where it is, right? We drop in here. If low is greater than or equal to high, well, low is equal to high. So now we have the answer. The answer is nums at low, 4, which is right here. And that is the correct answer. 1 is the minimum. So, okay. Key takeaway here is you can binary search a sorted list or array even if it's rotated. Okay, let's go ahead and try to run this. Get rid of that. And no. I got to get rid of that too. And hit it. Okay, thanks for watching. If you found this helpful in understanding a little bit more about binary search, go ahead and hit like, subscribe to the channel, and check out the playlist on screen. There's a lot of videos there that will help you level up your interview skills. Now, the video description and the pinned comment have a link to a free coding interview patterns PDF, which if you're in the interview loop, I think will help you. One of the patterns is binary search. You can download that for free immediately. And that's it. We'll see you next time.